So, once again, good afternoon, everybody. So, I'll be starting a session now. So, Henry, you're welcome. Mr. Henry, you're welcome. Thank everybody for being present. And so we'll be going over pandas. And what we'll basically be doing today is I will introduce you guys to pandas. Pandas is a package within Python that allows you to manipulate tabular data. So data in the form of tables like Excel, CSV, spreadsheets, and all of that. We can do some manipulation with it using pandas. Now, the thing about pandas is that there is a bit of coding attached to it. So that's one thing you should know when using pandas. There's a bit of coding attached to it. So it's a package in Python. So I'll just basically be introducing everybody to it. And then we'll see how to kind of prepare a very simple data sets for, let's say, you want to train a model for, let's say, a classification or a logistic regression like we discussed before on Monday, or for, let's say, linear regression. So I'll just be going through that stuff basically. So let's begin. So there's too many parts to pandas. There is series, there is data frame, there is missing data, there is group by, there's many, there's join, there's concatenation, data operations, and there's feature generation. So the very core concept of pandas is something called a data frame. Okay. Now, a data frame is basically just what you know as your usual tabular data. Something like Excel now. If you import an Excel file into pandas, okay, because Excel file is a file format in Excel, right? But if you want to import that kind of data towards pandas, the way the data is imported as a data frame. So a data frame is still the same thing as a two-dimensional data, okay, like you see in Excel. It's still a two-dimensional data in Excel. Like it's still a two-dimensional data, I mean. So there is also series, okay? This number 3 here, that's the data frame, okay? Now, a series is like a smaller version of a data frame. What I mean is if you have a data frame as a two-dimensional data, okay, with rows and columns, then a series is a particular row. So we can generally say that a data frame is a combination of series. So a column, one particular column is a series. So if you have two columns together, you have what? A data frame. You get? So a data frame is a combination of series. That's a very simple explanation for it. So you can say a series is like a column, okay? So I will be doing some coding, so we'll see how these things actually work really. So when you are actually deciding to manipulate data, okay, with pandas, there are so many methods and functions and ideas that you could decide to use during your manipulation and all of that. Those are the stuff we call, there are different ones like group by, merging, joining, concatenating, feature generation, and all of that. So, but it's okay to not fully grasp what I'm saying now. It's very okay. When I begin to show the coding and all of that, you'll begin to understand everything I'm saying, okay? So it's quite okay to not fully understand it. So let's just flow. So here's a brief history of how pandas was created. Okay, it was created by Wes McKinney, and it was created between it was released in January 2008. So the thing about pandas and a lot of the packages within NumPy, because within Python, I mean, because Python is a programming language of itself, and there are different packages that have been built on top of Python that allow you to do various things. Normally, pandas is not a package that came with Python. You have to install it separately, and it's not hard to install. It's just a simple pip install. But the way these packages are built on top of Python is such a way that they are built up as open source packages. What open source means is that normally in traditional software development, if you are developing apps or software for use, what you do is you build it from scratch yourself, and then you have sole control over that app or that application. And then when you build it, you ship it out and give people a place to download it or install it. But the way open source packages work is that no single person has full control over it. Okay. Now, if I build a package and I want to make it open source, I build it and I share the code out for everybody to see. Okay. So when I share the code out for everybody to see, anybody could just go there, copy it, and just copy what I did. Okay. Now, the way you share your code out, the most common way is to use GitHub. So that's it's an open source environment for sharing of code. So anybody can go there. Maybe there's an issue with one part of the software you created, like this case pandas. Anybody can go there, generate an issue and say, okay, there's an issue with this part of the code. I think there's an issue here. Now, the difference between open source and normal closed packages that people create, like companies create themselves, is that with open source, you can actually go to the code base, make the changes you want to make by yourself. Anybody can go there and make the changes. But the only thing is that it is now left for the person that created the software initially to accept your change or not, because there has to be some kind of a governance structure around the changes that can be made to a software. Because if anybody can just go there and change something, then there should be a way to verify that what you actually changed is actually right and it actually works. So the only thing is that somebody has to be there to actually accept it. So that's the guy that originally created the software, but anybody can go there and make their changes. That's one of the things about open source packages that work around NumPy. So around the Python, I mean. So pandas is an open source package. NumPy is for numerical computation. It's also an open source package. There's various kinds of open source packages. There are too plenty. Scikit-learn, SciPy, just too many. So that's what basically this stuff are. So, like I said, a series is basically a column in a data frame. So as you can see over here, this full stuff here, this is like something you would easily see in Excel or in CSV. Okay, it's something you would easily see as a table. But when you bring it into pandas in Python, it's now called a data frame. So here we have the names of the columns, and here we have the rows. Okay, so and there is many things that could happen. Same way in Excel, where if you have a data set, there could be points in that tabular data where data is missing or empty spaces. So if you also import that data into pandas, pandas does not leave that space empty. Okay, so what pandas does is that it replaces it with a NaN value. Now, what a NaN value basically means is just not a number. Okay, something like nothing is there, but it replaces with this value to let you know that nothing is there. There's nothing in that space. So this is an example of a missing value in a data set. Okay. So what we have here, these are the indices that we use to represent the columns, and these are the indices, the names of the columns. And these names of the columns are what you use to reference, the columns and the parts of the data frame later on. Okay, so as you can see, each column here is a series. So when you join these columns together, you get what? A data frame. Okay. So if you understood that, please let me know in the comment section. I would love to get feedback as we go on throughout the session. If you have any questions, please just let me know immediately so that we don't go back and forth. Okay, thank you very much. Okay, let's move ahead. Okay, so Data frames are, okay, pandas data frame are two-dimensional size, mutable, potentially heterogeneous tabular data structure. Okay, too many English here, but it's okay. So basically what this stuff is just saying is that what I'm saying here is just that a data frame is a two-dimensional structure, like I've said before, and it's aligned. They have rows and you have columns. Okay, a row is from left to right, horizontal left to right, like this. This is a row, left to right, this is a row, and this is a column. This is a column, this is a column, and this is a row. So rows are left to right, and columns are top to bottom. So that's basically what this stuff is saying here. So there is in the case of missing data, like I described before, say when you import the data into Python, where there are missing parts, like in this case where there is a NaN here, like I said before, if you import the data into pandas data frame, what pandas represents those empty spaces as, it puts a NaN there, this NaN, to represent that there's nothing there. Okay, so normally, depending on what you actually want to do, there are times where you actually need to fill in those missing values. Now, you will ask, how can you fit in values that are generally missing? So there are many ways. There are sometimes where you really don't need to actually fill in those missing values. There are some models, okay, that can handle missing values. There is models like XGBoost. XGBoost can handle missing values in some cases. So one way in which it handles okay, let's say you have a column, okay? Let's say you have a particular column here that has just two values in each row, maybe left, right, left, right, left, right, okay? This column is left, this column is right, this column is left, this column is right. It's like there's a value, left, right. We are discussing maybe hand. Hand is the name of the column here. And you have left, right, left, right, left, right, left, right here. Let's say you have a missing value within this column, okay? Now you know that there are only two values that could be there. There could either be left and there could either be right there, but it's missing. So one way in which XGBoost works with those missing data is by choosing a default setting, assuming a default setting within a particular column if there are missing values there. So what it does is that if you are training the model, it assumes, let's say they are left and right first, it assumes all missing values to be left, to have a value of left. Then it trains the model on it. And then it will also try to assume all the missing values as right and compares the results. So models like XGBoost can actually handle missing values. But there are also some models that cannot handle missing values. There are some basic linear regression tend not to accept missing values. So you have to fill it with something, anything that comes to your mind. And not really anything per se, because if you fill it with anything, you will just complicate the data. So there are multiple ways of filling missing values. The first one is doing nothing, like the one I said before, like XGBoost can easily handle it. So it's not as if you just can't fill, you must not fill when you're using XGBoost model, okay? But you can decide not to. So this thing is all based on your decision. It's based on intuition. So there's really no hard rule on this. It's based on your decision or your intuition. It's based on the data set you have and what you feel will be best for the data sets. Okay. If I feel if I feel these missing values, will it be better? If I don't feel it, will it be better? So it's basically based on your decision. So that's why do nothing is also an option. It is also imputation. One way in imputation is doing imputation works is that there are many methods of imputation. There is filling it to the mean of the remaining data within the column. There is also filling it to the median. There's also filling it to the mode. Okay. So let's say this is a data set now. Okay, there's 0, 30, 8, there is 12, there is 7, there is 11. I want to fill in this data, this particular one here. So one thing you can actually do is to just take the mean of all these values here and replace this guy with it. So you can say 30 plus 8, 0 plus 30 plus 8 plus 12 plus 7 plus 11. Then there are 6 values, right? Divided by 6. and then you replace this guy with 6 with the result you get. So anywhere there is a none in this particular column, it is replaced with that value. Okay, so that was one way of actually replacing values. And it's also using median. Okay, so you have 1, 2, 3, 4, 5, 6 values. So how does median really work? You have to arrange the values in an ascending order. So if you're going to arrange these values in an ascending order, what you have is 0, 7, 8, 11, 12, and 30. I'll go again in an ascending order. 0, 7, 8, 11, 12, and 30 in an ascending order. So what you do is when you arrange these numbers in an ascending order, you pick the median, the median one, the one at the center. But in this case, because we have two numbers at the middle, so if you have 6 values, if you want to pick the median, it should normally be between the third and the fourth value. Okay? You have 6 numbers and you want to pick the median. It should normally be between the third and the fourth value. But because you have 2 values here in the middle, what you can basically do is just to take the average of those of those 2 values, and you get that as a median. So in this case, now we have 0, 7, that's the second value. We have 8, that's the third value. Then we have 11, that's the fourth value. So our median will be between the third and the fourth value, since we have 6 numbers here. So what we'll just do is 8 plus 11 divided by 2. That's 19 divided by 2, that's like 9.5. So your median becomes 9.5. So what you just do is that you replace everything here with all the missing values here with 9.5. So that's using median. Then there is also mode. Okay. So mode is just basically using which particular number occurs the most. Now, in the case of mode, it's kind of usually used when you have discrete data. The data set that has discrete values. Now, when I mean discrete, discrete is different from continuous. They are 2 different things. A data is discrete when it can only assume a particular category of numbers. Okay, so if I'm saying number of oranges can only be 1, 2, 3, 4, 5, 6. Okay, I shouldn't be able to say I have 1.5 oranges. It wouldn't make any sense. Okay, so when you say discrete, that kind of counting is called discrete counting, because I'm saying it can only be 1, 2, 3, 4, 5, 6. There can't be anything in between. There can't be 2.2 oranges. Okay, so of course it could be possible if you are doing mathematics and all of that, but in the case of discrete counting, in case of discrete versus continuous, that kind of a system is called discrete. Okay, so continuous allow when you're talking about continuous data, you're talking about the kind of data set that allows for any kinds of number. So I can have points, I can have decimal, I can say okay, I can say in the case of electricity, you can say 2.2 volts, 2.2 this and all of that. So there's points and all of that. So there can be a range of values. Okay, like you can say 2.3, 1.5, 6.7. Even naira is kind of even if you're talking about currency is actually continuous in a way. It's continuous because you can have 2 naira 50 kobo. Okay, but if you're talking about discrete data, there is no another way in which you can know discrete data is data that has to do with categories. Okay, like as you can see here, first, second, third. Okay, there's nothing like second and half. There's no second and half. It's either you are first or you are second or you are third or you are fourth and above. Okay, so that's basically the difference between discrete and continuous data. So like I said, mode is usually used for continuous, mostly discrete data, sorry. So with discrete data, what you do is you just pick the most common value within here. So let's say in this data set now, there's 0, 30, 8, 12, 7, and 11. So maybe we'll have another row now where there's another value 30. Okay, so in this case, 30 will appear twice. So we can say that 30 is the mode. Okay, 30 is the mode of this data set. So what you just do is basically picking the one that appears the most. So there is backfill and forward fill, but those ones are not usually used a lot. It's not usually used a lot, but I think I'll just go over it briefly. So I think with backfill, what you're actually doing is that Backfill and forward fill is that you're actually using what's in the previous row, like here now. You're actually using what's in the previous row to fill in this one. So assuming there is a none here now. There is a none here and there is a none here. Okay, that's missing value here. Backfill and forward fill can allow you to fill this guy here with this value here, or you can fill it with this, you can fill this guy here with this value here. So it just fills with the value on top or the value below. That's backfill and forward fill. Okay, so that is not mostly, it's really not used as much. So there's also a more advanced method, KNN. So KNN is a more like a it's an ML model of its own. K-nearest neighbors. So I won't be talking much about this. I won't be talking much about this, but this one is quite advanced in a way. So unless you've actually started to use pandas a lot before you can make it okay, think of how to use this kind of method. So, but just like actually involves using the nearest what this guy does is that it groups data into how close they are with each other. Okay, it tries to group data into how close they are with each other and tries to find a way to replicate an unknown value based on some other features they have seen before. So that's basically some simple explanation about it. So like I said, today's session won't be long at all. It won't be long at all. So I won't stress you guys with too much talk and all of that. So okay. So if you understood everything I explained about solving messy data, please let me know. Please let me know in the comment section. Okay, thank you, Ebuka. Thank you so much, Ebuka. Thank you. Okay, thank you, Oyeniko. Thank you. Okay, so moving forward, there is some basic syntaxes or syntax that we can use when you're working with pandas. There is group by. So group by can be used for grouping data. Okay, so okay, we'll see this as we go forward. We'll see this as we go forward. Okay, there is also merging where you want to merge multiple values together. There is also join. Okay, you can join multiple arrays, multiple series together and all of that. Then you can also concatenate. These are all various forms of joining in a way, but this group by is for grouping data sets. Okay, you can group particular values together so you can work on them. So I'll be going over this when we start the code. So as you can see here, this is data set 1, this is data set 2. And when you concatenate both of them together, what you're just basically doing is you are joining them together. So you have this row, it comes here, this one comes here, this guy comes here, and this guy comes here. So as you can see, we'll be able to join this data set together with concatenation. Now, as you can see, it still retains the index that it has here before. But normally after concatenating, it's always advisable to reset this index so that it starts from 0, 1, 2, 3, and above. Okay, it's usually very, very, very advisable because the way in which you, just like in Excel, if you want to access a particular value, you kind of use, if you want to access the value in column A, as in Excel, now you know the columns are represented with letters, column A, row 2. So you use A2, Karen, right? So it's also quite similar here, the way you reference a particular value. You can actually use the column name and the index. So if you have 1, 1 here, and you want to reference, if you want to reference Imana, and you use name and 1, column name and index 1, you will have some kind of conflict because 1 here is representing Iman and 1 is also representing Rahul. Okay, so it's always best or advisable to reset the index after doing some concatenation. It's always advisable. Okay, so that's basically it for that. So for pandas, there is some data operations you can do with it. There is statistical operation. Okay, one thing I would love to mention is from the previous examples I just gave on mean, median, mode, you can see how much those basic statistical knowledge are very helpful when you're manipulating or using data. Okay. Now, those basic processes we discussed on Monday can see how useful they are, because in the end, no matter how, in the end, it's also still based down to intuition. How you feel your data should be manipulated, or how you feel what operation will be best to give an optimal kind of data. Now, one reason we do this is that okay, let's even discuss why do we even have missing values in data? Okay, what kind of scenario gives us missing values in data? I will give us an example. Okay, now let's say you have final year students. Okay, you have final year students and you've given them a task. Let's say you're a lecturer. You've given them a task to go and, okay, like I know in case of, I think, economic students, they have this stuff where they take surveys out and they give those surveys out to people to fill. Okay, now, usually what the students do is that they print maybe 50 kinds of 50 copies of that survey and they hand it out. Okay, now when you have, let's say, 20, it's quite easy to regulate. Okay, maybe you are standing by each person and make sure, okay, sir, please feed this part. Please, I need you to actually feed this particular part. Not everybody wants to fill every part of your data, of your questionnaire or your survey. Okay, not everybody wants to fill every part. So people can just say, okay, I'm tired, I beg. Okay, and if the number of survey you printed is like small, maybe 20, 10, I think it's quite easy to at least stay with each person to make sure they fill up everything as you need it. Okay, that's an easy part. Okay, this is during data collection. But let's say you have, about 100 surveys you printed or 100 questionnaires that you printed. I'm very, very, very sure there is almost no way you will be able to stand with everybody and make sure they fill up everything. There are many reasons. A lot of reasons. One, there are some people that won't just want to give you some part of their life. Okay. Now, if you have a questionnaire that maybe includes age, okay, so people may not just want to give you their age. They may not just want to give you their age. So that constitutes for a missing data. It's missing. So people may not want to give you their department. They don't want you to have it. Okay. Some people may not want to give you okay, maybe you have a part that maybe you want to know the range of their GPA. You want to know people that have GPA between 1 to 2, people that have GPA between 2 to 3. Maybe as part of the questionnaire. It's not as if it's the entire questionnaire. So people may not just want to give you this. So there are some people that may not want to give you certain parts of the data. Now, in this case I'm describing that where you have a large number of questionnaires, maybe you have 100, 200, there is almost no way in which you can regulate, you can ensure that everybody fills in everything completely. So when you take your questionnaire, you can decide to, okay, after taking your questionnaire, let me move it to a tabular data form where I can begin to process it and see what's going here and do some analysis. Now, the problem is that you've already had some missing values from your data. So that's how missing data, or those missing values like none and all that, that's how they come. They come during the data collection process. That's how they usually come. Then there is also something I'd love to talk about that is not here, but I'll just have to talk about it. There is also something called data quality. Okay, so data quality, what that basically is that in data quality, what happens is that during the phase of collection of your data, normally, logically, you are assuming that the data you've collected is correct. Okay, but that is almost not always the case in real life. It's almost not always the case in real life. And that is because some people, even if they want to, in the case of the questionnaire we are discussing now, even if they want to fill in the parts they want to fill, they may decide to give you wrong information. Okay. Now, in the case of a person filling their age, okay, somebody may not decide to fill their age. They don't want you to have that information. That is a missing value. Then there are people that will just also want to fill it, but they will decide to give you wrong values, wrong age, or maybe wrong date of birth or wrong year of birth. That has affected the quality of the data because those are wrong values. And the problem is you can't actually, how do I put it now? It's almost rarely your fault. It's almost rarely your fault. Now, for large organizations, they have methods around, there are methods called data governance. Those are methods that allow you to minimize erroneous data sets during the collection phase. They have methods that are basically around data governance that allows you to minimize errors when you're collecting data. But for a student like me that, okay, wants to collect data, it's almost, data governance is simply out of the topic. It's so much of an advanced topic that shouldn't be even be considered by them. So because it's just a simple questionnaire. So when you're collecting data like this, when you have data sets that isn't, you have wrong values within your data, you can't know if the data is wrong or not because it's not your age. Any age the person tells you, the person has told you, you can't know. It's not your age. Okay, it's not your date of birth. Okay, so this kind of cases are what we call erroneous data. These are data that have issues with quality. So there are many cases where this can happen. So that's basically that. So when you have all these cases, that's why when you get your data, when you now, okay, after extracting it, you want to now extract it from your questionnaire, okay? Let's say your questionnaire is a paper, or let's say your questionnaire is a Google form. You extract it and then you now pass it through, let's say an Excel file. So if it's an Excel file, normally there are people that can do good data processing on Excel files. There are people that are good at that, okay? Now, there's also you, the data scientist, who may decide to do this with pandas. That's what this, with Python, I mean. So that's what this session is mostly about, people that want to do it with Python, okay? So if you want to do it with Python, one of the easiest way is to import it into a pandas data frame, okay? So the reason we do all this statistical operation, feature engineering, feature selection, data transformation, visualization, and data processing is because of the issues with quality and missing values that usually come with data, okay? When you're collecting data, there is so much, how do I put it? There is so much outside your control there's so much outside your control that will affect your data. That's how we are doing all this stuff. So statistical operation, like we discussed Mondays, are things like mean, median, mode, and all of that. Now, feature engineering. Okay, I will discuss what feature engineering is basically. So, feature engineering. Okay, sorry. If you understand what I said around data quality and data missing values, please let me know in the comment section so that I will know you guys are following. Please, I don't want to be going too fast. Please, if you understand, just kind of say yes in the comment section. Thank you. Okay, thank you very much, Mr. Felix. Thank you so much. Thank you so much, Helen. Thank you. So back to the session, okay. So, and if you have any questions, please just draw my attention to it immediately so that we'll just treat it as it is. So what is feature engineering? Okay. Now, for me to explain feature engineering, I will go back to the original data frame that we had, this kind of data frame, okay? I'm trying to explain feature engineering now. Now, what feature engineering is that you have your data, okay? Your data is in its raw format. This is your raw data. Name, okay? Name are just letters, combination of letters, okay? You have team, this team here is also a combination of letters, and you have number, which is numbers, numerical values, okay? Now you want to train a model, okay? Maybe you want to train a model that can use the name and the team to predict the number that we get. Maybe I think this is around, let's say you are doing basketball, number of basketball, let's say football, okay, how do I put it? Let's say number of goals the person will score in a particular year. You want to use the name and the name of the player and the name of the team to predict the number of goals the person will score in a particular year, okay? Now, the first word there, the first phrase there is building a model. Now, a model in this case is a machine learning model. Now, like I said on Monday, when you are trying to train a machine learning model, we discussed something like importance the other day. Now, we said importance are randomly generated values within your machine learning model that your machine learning will learn to, your model will have to learn to be able to give you outputs. Now, basically what I'm saying is that the operations, the learning operation, the learning part in the computer is by numerical values. It is learning numerical values. And everything it needs to learn the numerical value has to also be numerical values, okay? So one simple explanation, one simple way to understand feature engineering data is one of those simple ways in which we can convert all these strings or names in letter format to numerical format, okay? Now, it may seem strange that you want to convert letters to numbers, yes, but it's actually possible. There are multiple ways of doing this, but I will show you some examples later on. I will show you some examples later on. So just understand that basic feature engineering is one of those ways in which you actually reconfigure your features so that they can be ready for, let's say, an ML model. Okay, because you can't pass in strings into an ML model. Strings, there are some ML models you can pass, but basic ML models requires a lot of numerical values, a lot. So your model has to have a lot of numerical values. Like these strings here have to be replaced with numerical values. Now, there are methods for this. We'll see how it is later on. So let's move forward. If you understood that, you can just drop it. Okay, let's see comment section. Okay, thank you. So there is feature selection. Okay, now up to feature selection. Now, what is feature selection? In feature selection, what we are basically doing is when you have a data set, okay, let me go it out. When you have a data set that has multiple columns, some of those columns will not actually be useful for what you want to do. Okay, some of those columns will not actually be useful for what you want to do. Because I will give, what example will I give now? Okay, let me give an example. Okay. Now you have a data set of students, okay? And you want to use, okay, you have secondary school students. Let me use it this way, secondary school students. You have secondary school science students, okay? Now, you want to predict, these are SS2 students, okay? SS2 second term students, SS2 second term students. Now, you want to predict how their chemistry results would be like at the end of third term, third term SS2 third term. Now, the data set you have is their chemistry exam score or their final result for SS1 first term, SS2 second term, SS2 third term, SS1 first, second, third term, and SS2 first and second term. You don't have the one for the third term. So I'll repeat that. You want to predict the chemistry, how the chemistry results for SS2 second term students will be like in their third term. So the data set you have is their result for SS1 first term, SS1 second term, SS1 third term, SS2 first term, and SS2 second term. So now let's assume the kind of data set you have. Let's say the data set has names, has their scores, final scores, has maybe their age, okay? Maybe you want to say age is a feature and all of that. Has their name, has their age, maybe has their parents' name and all of that. Now, you would agree with me that some of those features are not necessary. Like, there is almost no way you can predict the score of a student in the exam by their name. Like, you can't tell me all people that have their name as Ayomide will fail. It doesn't make sense, okay? You can't tell me all people that have their name as John will pass, okay? So name in this instance is a kind of a feature that is not needed to do whatever you want to do, okay? So that kind of a feature needs to be dropped from a data set, okay? It is not important, it is not necessary. So you cannot say features that may be necessary are, okay, features like their previous score, that could be very necessary. Then maybe their age, because maybe their age could also be necessary, but things like their name in the data set are not necessary because it doesn't really convey much. You can't tell me that people that have their name as Oye will fail. People that have their name as Taiwo will pass. No, it doesn't make sense. So name is a kind of a feature that is not needed. So it can be dropped. So that's a simple explanation around feature selection. Then we have data transformation. Okay. Data transformation is quite similar to feature engineering, just a few differences. But if you understand feature engineering, just know that data transformation is around that area too. So data visualization. Data visualization. Okay, before I go to data visualization, let me discuss one more thing about feature selection here. Now, when you are selecting your features, okay, you have a data set. Let me go back to the previous one here. You have a data set that has many features. Like this case, we have 3 features. Okay. Now, there's a number of reasons why you may actually want to drop a particular column, okay, or a particular feature. Okay, from now, when I say feature, I'm talking about a particular column in this case. Okay, just follow me. When I say feature, I'm talking about a column. So this is a feature, this is a feature, this is a feature. Okay, so there are a series number of reasons why you would want to actually drop a particular feature. Now, there is the obvious case, like I explained before, where like a name of a student doesn't really tell you much about the student. You can't tell me Ayomide or Ayomides are like this, or Iyobos are like this, or Peters are like this. It doesn't really tell well. So there are a number of reasons why you may want to drop features. There is one of those other way of deciding where to drop features is correlation. Okay. If you have a data set where 2 or more values are highly correlated, it's always best to drop one. Now, what does correlation mean? What does correlation mean in this case? Correlation is like you have a value for X. Let's say this is a column X and this column Y. Okay. Is there some kind of relationship you are seeing between X and Y easily? Okay. Now, I'll give a very intuitive example. Okay. Now, you say you want to go to New Benin. Okay. You leave Uniben. Okay. Now, let's say you leave Uniben by 10 a.m. I say you want to get to New Benin. Okay. Now, you will agree with me that the time it will take you to get to New Benin is highly correlated with the density of the traffic on the road, right? So you can see that the time taken to get to New Benin and the density of the traffic are highly correlated. They are very, very, it's like, I can tell you, how do I put it now? Unless, assuming you don't stop on the road, you don't stop to branch or something, I can easily tell by the time it took you to get to New Benin that, okay, there was most likely a high amount of traffic. Also, the same way, if I don't know the time it took you to, if I don't know the time, by the amount of traffic, like the amount of traffic on the road, maybe I experienced it, I can tell you, okay, to take you maybe 30 minutes to get to New Benin. So you can see with one, you can most likely predict the other. Okay. Now, this is a very simple explanation of correlation. Correlation gives you an idea of something else without from knowing another thing. So in this case, from knowing the density of the traffic in the road, I can easily predict when you will get to New Benin. Same way, if I know the time it took you to get to New Benin, I can easily predict, okay, since there's high amount of traffic on the road. So there's a very high amount of correlation between those two features. Okay. Now, in statistically, okay, because what I just explained just now is just an intuitive explanation. Okay, high. But what defines high? What defines low correlation? Okay, what defines high? What defines low? How do you define high and low? Statistically, there is something called Pearson correlation. It's a mathematical formula. You can always read it out. I will just put it in the comment section. Let me put it to everyone. Okay, Pearson correlation. It's a statistical method of deciding how much 2 values are correlating with each other. Okay, so correlation is usually measured as a percentage. Okay, it's usually measured as a percentage. So if I can say there is a high, let's say the time taken for me to get from Uniben to New Benin correlates with the amount of traffic on the road by like 80%. You see the way I'm measuring it. 80%, 90%, 70%. Now, what defines a high correlation is not, there is no hard rule on how you define a high amount of correlation, okay? Some people use 70% as high amount of correlation. Some use 90%, okay? Some use 60%, some use 80%. So there is no hard rule on this, but for me, I usually use 70, 80. You can even go as low as 50, depends on your data set. So that's why I say a lot of the stuff in data science is based on intuition. So what I'm basically saying is that as you begin to practice more and more, and you begin to do more stuff with data science and AI stuff, you begin to understand how you define your threshold of high and low correlation from experience. Okay, so experience is still boiled down to experience here. So experience will actually tell you what you will define as high and what you will define as what low. So let's see. So I don't know if you understood correlation. You can just let me know. That, if you have any questions, please just let me know in the comment section so that we can just treat it immediately. So visualization. With visualization, what you're basically doing is you're visualizing some key concepts in your data set. Okay. Visualization, yeah, like I will repeat, you are visualizing some key concepts in your data set. Now, there are very ways you can visualize. There's many ways of visualization. There is graph plotting, there is bar charts, there is histograms, there is normal XY graph, there is 3D plots, okay? There is numerical, there's many forms of plots, there is pie chart and all of that. So why do we really need to visualize data? Why do we need to see plots of data? There's a lot of reasons, actually. So one of those reasons is one of those very important reasons is called data, to know if they are imbalanced data sets. Okay, they are imbalanced data sets. If your data set is imbalanced. Now, what do we mean by a data set that is imbalanced? Okay, a data set is imbalanced if you have some examples within your data that are so much more than other examples in your data set. I will give you an example. Say you have a data set, okay? I will use a very extreme example now. I'll use a very extreme example. So you have a data set that you have to classify, okay, people that, okay, you have a data set you have been given to classify people that are terrorists from people that are not terrorists, okay? You have given the names of past terrorists that's in the database. You have been given the names of people that are terrorists before, their names, where they are from, their age, their dates of birth, location, and all of that, okay? And maybe you are giving 100 rows of data, okay? That's 100 different people. And you're also giving data set of people that are not also terrorists, okay? So your aim is to build a machine learning model that can identify terrorists from non-terrorists, that can distinguish them using data features like their name, their age, date of birth, location, where they were born, school they attended, all of those stuff, okay? Now, we have two classes here, terrorist or not terrorist. You have two things you are trying to build a model for. Now, in this case, you would agree with me that that not everybody you see, most of us have never met a terrorist, and most of us will never meet a terrorist in our lifetime. So you can agree with me that maybe 1 out of 1,000 people, 1 out of 1,000 people can be a terrorist, 1 out of every 1,000 people. Now, if you do the mathematics, you will see that 1 out of 1,000 is like 0.001%. Oh, sorry, let me say 0.1%, I think. 0.1% of everybody, okay? So 1 out of 1,000 is like 0.1%. So you're trying to say that if you have, let's say, 100, okay, let's say you have 1,000 people, 1,000, you be giving an example of 1,000 people. And it's out of that 1,000 people that you're giving, 999 of them will not be terrorists, according to the labeling. Then one person will be a terrorist. You can see how imbalanced the data set is. Okay. Now you have so much more people that have been labeled as not terrorists than the people that are even terrorists at all that you are trying to target. Okay. So one way in which now it's easy to say you can just check terrorists on just count it easily when you have it's quite easy to just say, okay, let me count the people that are not terrorists and count the people that are terrorists and just see if the difference is too much. This is easy if you have just two labels, terrorist or not terrorist. But there are cases where you have multiple labels. Like in the case of, let's say you want to classify different animals, okay? You are building a model to differentiate dog, cat, mouse, rabbit, and all of that. There are cases where you will have much more examples of dog than you even have of cats, okay? So when you have too many classes like this, one way to easily see which one is best is to visualize, okay? Is to visualize. Now, another reason to visualize is that you can actually see trends when you visualize, okay? Now, what do I mean by trends? Say you have a data set of monthly sales. You are a store owner. You have a data set of monthly sales. Okay, January you sold 15,000. February you sold 200,000. March you sold 10,000. If you plot this stuff on a graph, and the horizontal part is the horizontal part is the months, the name of the month, and the vertical part is the amount sold, you can actually see a trend in how much your sales are. So there are sometimes where you don't really need to, if you are doing some analytics is basically trying to generate insights from data. Visualization is a very key tool. Now, visualization is usually done with another package, not pandas. Sorry, I didn't mention that. It's called Matplotlib. Someone else will discuss that next week, really. So apart from Matplotlib, which is a package within Python for doing that, there's also other well-specialized packages for doing this at an enterprise level. That's if you are doing this for, let's say, a large organization. There are packages like Power BI. There is Tableau. Those are packages that apps or tools that you can use to develop visualizations at a very high scale. So if you understood everything I just said here, from statistical operation to feature engineering to feature selection, please let me know in the comment section. It seems I've said a lot, so please let me know so that if you have any questions, you can just ask. I want to be sure people are following me, please. Okay, thank you, Ebuka. Thank you very much. Thank you very, very much. Okay. So data preprocessing, it's basically most of all this stuff joins together. That's basically what data preprocessing is all about. Basically, most of all this stuff joins together. So remember, like I said, the main aim I have here is to give you an intuitive understanding of most of these concepts, because almost anyone can easily go and learn pandas and all that, but it's not as easy as it gets to actually have an intuitive understanding of these terms. If you look at the terms like correlation and all of that in the mathematical scenario, like when you browse, you most likely see things, you see mathematical formulas and all of that. They can be quite confusing. But if you understand the basic concepts behind this stuff, you will see that the equations are just equations, okay? But the concept, the intuition is what matters the most, really. So let's move ahead. So feature engineering, feature selection. Okay, so remember I said I won't waste much of your time today. So what I'll just do, I'll just open my notebook now. I will just show you some code of how we actually do some of these manipulations, like I said. So today, I will be using a very simple data set, a very, very, very simple data set to show you some examples of how we transform data, okay? Very simple data set. So I will be going in depth, just surface level. So okay, let me make this screen white so that you can actually see it clearly. Okay, I'm sure it's better like this now. So first thing first, here we import, okay, let me remove this guy. We import pandas as PD. This is how you import packages in Python as PD. So we import, and then pd.read.csv. I'm trying to read in a data set. Now you can see this .csv, it's a CSV file, okay? So if I read in the CSV file, this df. So this df here, like I said, data frame. So I'm abbreviating its data frame. Now we said the data frame is like a tabular data. So df.head means I want to see the first five rows, okay? So if I do this, as you can see, the first 5 rows, you see the features unnamed 0. This one I can remove it. There's index, there is member number, okay? There is date, there is item description, there is amount, there is day of week, there's months, there's week, there's month, okay? So I will give you an explanation of what this data set is. This data set is actually a data set describing the people that comes to, it's a data set of the people that came to buy something in a shop for a particular period of time. Okay, so this member number here is it's an identifier. Okay, it's like something that represents a name of a number of a person. Now, the reason, okay, let me just explain something. Now, take this row here. Okay, now you have a member number, you have a date. This is the date they made the purchase. These words they bought, tropical fruits. This is the amounts they spent in buying that fruit, that stuff. This is the day of the week. This is the week of the year. You know, there are 52 weeks in a year. So this is the week of the year. This is the day of the month. Okay. Now, for this member number, now you would agree with me that it would have been better to have the name of the customer here. Okay. Now, there is a reason why it isn't here. Okay. There is a concept called data privacy. Okay. Data privacy is more like a regulatory system within a particular organization that allows you or that restricts you from sharing excess information or collecting excess information. Okay. So in the case of, let's say you're a data scientist and the company gives you that data to help them process or find some insight to it, there are some data that will be removed before they will give it to you. Even if they are not removed, they will be masked, or they will use some random values to represent some stuff there. Now, the reason they are doing that because of data privacy, because there are some regulations, like there are some regulatory bodies in Nigeria like NITSTA, okay, that have some kind of rules called NDPRO. NDPRO are rules that prevent you, it's like a regulatory rule that prevents you from sharing too much data with outsiders. Because you are a company, I'm a data scientist, I'm not in your company, but you are giving me your data to help you process. Before you give me your data, there are some rules I will have to follow. And some of those rules states that I have to remove too much, they call them PIIs, personal identifiable information. They are information that I shouldn't have because I can actually do my job without having those information, okay? So those regulatory systems are in place in case this data leaks out somewhere. So imagine seeing your transaction history online at some website or something, it can be very bad. So, and there's usually some fines that come attached with it. So it's one of the reasons why you are seeing member number here instead of name. So because of those regulations. In Nigeria, we have NDPRO, but if you're in European sites like Europe, they have GDPRO, they have the European Union that manages data privacy, but this data privacy stuff is usually for organizations, not usually for small stuff like this. So that's basically, this member number is just anonymizing the person's name and the details. So that's basically what's going on here. So now this is a data frame. Like I said before, this entire stuff is a data frame. Now, if I want to select dates, what I do with pandas is df. I write the name of the data frame, df. I put my square brackets, then I put the name of the column. You can see dates. Now, the name of the column is case sensitive. And if you are using capital letter here, it has to be capital letter in your naming too. It's very, very important. It's very case sensitive. So as you can see, this one also has to be capital letter here. So if I run it, you see I have just the date here. Okay. Now, this date here is something we cannot call something like a series. Okay. So can I call it something that looks like a series? So for someone who output my day of week, I cannot say day of week. As you can see, okay, I've outputted my day of week. Now, let's say I don't want to use all my features. I don't want to use all the features. That's in the case of feature selection, as I explained before, feature selection. I want to pick, okay, I want to pick only the day of week. I want to pick only amount, week, and day of month. I don't want to pick the rest. So what I want to do is, I want to use another data. I want to store it as another data frame. Let's say df2, okay? I want to pick amount, week, and day of month. I will say df2, that's my new data frame that will contain only amount, week, and day of month. Will be from the previous data frame that contains everything. I will pick only, you see, I will be using double brackets here, okay? I will pick amount, okay? I will pick day of week, and I will pick day. Okay, so what I will do, Abdul Hamid, I will actually share this file, okay? I will share this file later on in the group chat, so you will see it. I didn't actually share this data. Okay, yeah, I will share this file and the data sets with you in the group chat later on today. So just bear with me. Thank you. So I will pick day of month, and then when I output my data, this is the new data df2. If I want to view this data, like I said, .head to view the first 5 rows, I will have only amount, day of week, and day of month. Okay. So as you can see, we've gotten only these 3 columns. So this is how you pick a particular value. You pick values and columns from your data set that you want to use. Okay. There are other methods, of course, there are other methods, but you can always, it's always good to know one. Okay. You can decide to know more later, but as for instance, it's good to know one. Then you can decide to know more later. There is drop, but that's also another method. So now, one very important thing I would love to discuss is that conversion of numerical values to of letters, okay, to numerical values. How do you do that? Because that's one of the very important things I would love to discuss. Now, this part here, let's say we are working with this df2 data set and df2, okay? We've removed all this unnamed 0, index, member number, dates, item description, and week, and all of that. We are left with this guy. Now, how do we, because like we said, we don't want to pass letters or strings into our ML model we were trying to build. We want to convert this to numerical values. So how do we convert these guys from letters into numerical values? One way to do that is to use something called apply. Okay. Now with apply, what you do first is to generate a map. Okay. So what a map is, in this case, is a dictionary. I will just show you what I'm talking about. So let's say convert. Okay. This is the name of the file, name of the variable. So what I'm saying is that anywhere I see Monday, okay, replace it with 0. Anywhere I see Tuesday, replace it with 1. Anywhere I see Wednesday, replace it with 2. Anywhere I see Thursday, replace it with 3. Okay. Anywhere I see Friday, raised to the 4. Anywhere I see Saturday, raised to the 5. Anywhere I see Sunday, raised to the 6. Okay, so this is like something I will use to convert this guy from day of week, from strings to numbers. So now I have my map. This is my map, something that helps me to map from letters to a number. So how do I now apply this? What I'll do, I'll pick, the way you choose what you want to do is that you pick the particular column you want to work with. How do you pick a column? You first have to know the data frame you're working with. The data frame I'm working with now is DF2, not the first DF. I don't want to touch this DF. I want to tamper with this DF2. So I say DF2. I pick the column I want to work with, which is what? Day of week. Day of week. Okay. So I'm not saying that this day of week, I want to do some action with it. I want to do some action on it. Now, the action I want to do on it, I will have to first, okay. Okay, just follow me. DF2, day of week. Okay. Dot apply. Okay. Now, what is apply does? What is apply does is that it allows you, normally there is a lot of values in this row, in this column. I mean, there's a lot of values in this column. What apply does for you is that it allows you to perform operations row by row very fast. It allows you to do the same thing for all rows very fast. Okay, so what I'm going to be doing here, I'm going to be using a lambda function. Okay, so what a lambda function is here is that I'm going to be saying lambda x. Okay, now this lambda x means pick each value. Okay, let me not use x. Let me use something very intuitive. Lambda day. Okay, for each day, that's what I'm doing now. For each day, I'm going to replace that day with convert day. So let me show you, let me explain what this function is doing here. Okay, now this lambda day means I'm taking each of these values one after the other. I'm taking these values one after the other. Okay, that's what each one is going. Now, what does this guy do here? Okay, let's say day is equal to, let's say, assuming it gets to a point where day is Monday. Okay, Monday. Okay, now what does convert day return? Now, this convert here, remember, it's a map we have here. Then we are passing in this day, Monday. What it will return? It will return the value associated with Monday. Okay, so if I print convert day, you will see, okay, I've not run this column, sorry. I have to run this column first. So you will see it returns 0, okay, which means Monday is associated with 0. So if I replace this with, let's say, Saturday, convert day will return what? 5. Can you see it now? So it's picking each day and replacing the value there. It's picking each day, this function here. It's picking each day and replacing it with these values that we'll set ourselves. Okay, so if I run this column, let me see. Okay, so it works. So if I view this DF2 again, as you can see, this data set, you see there's letters here. Now we don't have letters here again now. We don't have numbers. Okay, so with this function, I'm able to replace anywhere I see numbers, anywhere I see letters with numbers. Okay, So that's basically it for, let's say, replacing letters with numbers. Here is how to numbers. Hello? Someone saying, trying to say something. Okay. So there's also many other functions you can do here. There's, excuse me, sorry, let me solve this noise issue. Sorry. Give me a minute. So there is also, please, if you understood that, let me know in the comment section before I move ahead. If you understood what I just did, just let me know in the comment section before I move ahead. Okay, thank you very much. Thank you. Thank you so much. Okay, so there is scaling I discussed on Monday. I would love to just touch scaling before we end the session here, because we can't really, Pandas is a very wide, it's a very wide package, very, very wide. And there is no way we can cover Pandas within 2 hours. So there's no way. So what I'm going to do, I will just touch a bit of scaling and then we kind of close the session for the Pandas today. But if you have any questions regarding Pandas, maybe you are learning and you have some issues, always feel free to drop your questions in the group chat, in the WhatsApp group chat. Feel free to drop your questions in the WhatsApp group chat. One of us will get back to you. One of us will definitely get back to you. Okay. So feel free anytime, any day. So I'll just describe scaling, what scaling basically is about. So I will use one particular column to describe scaling. I will just use week. I will use this week column to describe what scaling is. So week, remember, I want to pick only this week, just this week column. And this week column is coming from what? DF, right? So if I want to pick this week, I will say DF, then I'll pick the week. So I would say week equals to DF what? Week. Okay. And if I view it, what would I have? Sorry. Okay, I'm using AK, sorry. I have this. Okay. So the scaling I want to do is a very simple scaling. I don't want to do something too stressful. Just a very simple min-max scaling. Okay. Now, what min-max scaling is basically about is that I want the maximum value in this full row now to be 1 and the minimum to be 0. But if you check this week now, if I do week.max, I want to get the maximum value. Okay. And I do week.min, the minimum value, you will see that the maximum and the minimum value are 53 and 52, 53 and 1. Okay. Okay, 53 and 1. Now, I want all the values to be between 0 and 1. I want to have something like a continuous value. I want to have continuous values. So one easy way of doing this, is to say, okay, I want to divide all the values by the maximum value. That's one of the very simple way of min-max scaling. Very simple. Divide everything by the maximum value. So what I can just do is I'll just say the new week, okay, week new is equal to former week divided by week.max. So I'm not dividing everything by the maximum value, okay? So we have our new week. And if you look at it now, you will see that we now have what? We now have what? Continuous values. Now, if I now show you the maximum and the new minimum value of this guy, you'll see it's now within the range of Okay, we still haven't gotten to 0 yet, but it's still okay. The maximum value is now 1. Okay, so you see, we've been able to achieve our aim of what? Min max. Okay, so there's so much more you can do with pandas. There's so much more you can do with pandas. So much more, so much more. But I think I'll be ending this stuff today. I'll be ending this part here today. But I think one thing I'll just let you know is that the intuition about this stuff, intuition is what matters the most. You can always Google what is max, how to do min, how to do max, how to find values, how to do this, how to do that. You can always Google the stuff, but the intuition of what you need to do is what is why I try as much as possible to explain to you. The intuition is so much more important than every other thing here. Because when you understand the concept intuitively, you can begin to decide where I want to use max, where I want to use min, where I want to use min max scaling. Here I want to use where I want to drop features, where I don't want to drop features. The intuition is so important. Okay. So if you are learning this stuff, please try as much as possible to focus on the understanding of the concepts. Anybody can Google syntax, coding syntax. Anybody can Google it. Anybody. It is not hard. Even me, I still have to Google the syntax almost every time. It's not as hard as you think. But the intuition is what matters the most. It really matters the most. Okay. So if you have any questions, please, you can just drop it in the section, in the comment section, so that we'll just pick a few questions, please. If you have any questions, just let me know in the comment section. Questions. Thank you. No questions? Yes, I say too. I think, yeah, a lot of practice will be very important. Yeah. A lot of practice, because like I said, intuition, like I explained today, everything I explained today may be you may understand everything today, but when you actually go back to actually work with this stuff yourself and work on projects yourself, you begin to learn things that you will not be able to learn from anywhere, from any course or any stuff at all. Begin to learn things that you will not be able to learn from anywhere. Experience is always the biggest factor to becoming good at this data stuff. Experience is always the best. It's always the best. It's always the best. So you are quite right. You are quite right. Experience is very important. So okay, any more questions? Precious. Yes, the recording registration will be available. It will be uploaded in the YouTube channel most likely tomorrow. Most likely tomorrow. Most likely tomorrow. Okay, so I'll be giving the floor to Peter now to speak. So thank you very much. Thank you so much. I'll be giving the floor to Peter now. Thank you. So Peter, you can take over now. Thank you. Okay, it seems Peter is not around. Okay. Yes, you can use Anaconda. Abdul Hamid. Yes, you can use Anaconda. Yes. Anaconda is quite easy to use. It's quite easy to use. Quite easy to use. You know, with Anaconda, you can install all your packages that you need within a particular part, one particular point, and just use everything you want to use. If you have any issues regarding using Anaconda, you can always reach out to anybody within the group chat, and someone will get across to you. Just drop your questions in the group chat. Someone will definitely get across to you. Okay. So you can just follow us on group chat on LinkedIn, Twitter, Medium channel, and all of that. So just to get updated with every event that we hold once in a while. So just follow up, join the group chat, join the WhatsApp channel, be active and all of that. Okay, Mr. Shina, okay. Maybe just drop this exact question on the group chat and I will reply you. I will reply in the group chat. Better receiving. Just drop this question, Mr. Shina, in the group chat and I will reply you. Okay. So there are awesome write-ups on our Medium channel, so you can always check them out. Okay. So just Mr. Shina, just try and drop this question in the group chat and I will reply you. Someone will reply you. Okay. If it means us holding a video call with you and going through the process with you step by step, we will definitely do that with you. Okay. We will do that with you. Okay, so thank you very much, everybody. Thank you so much for attending today. Okay, Precious. Okay, Precious, just okay, Precious, just DM me your number here so that I will give it to the person that will add you to the group chat now. My name is Iyobosa, so just look for it in the chat section and just send it to me directly, privately. Okay. Okay, Peter wants to drop the link. I think Great in AI Community, that's the name of the group chat. Great in AI Community. Great in AI Community. So Precious, Peter will share the link to the group chat now. So you will have it. So very soon. So let's just give him a few minutes to share that link. Okay. So the link is in the comment section and you can just the link is in the comment section now. You can just click it and it will take you to the group chat. So Mr. Shina, the group chat we are talking about is in WhatsApp. The group chat we're talking about is in WhatsApp, actually, WhatsApp. The link to the group chat is already here in the comment section. You can just click it and it will take you there. Or if you don't want to do that, you can as well drop your number directly with me and we'll add you to the group chat later in case maybe your Zoom, your WhatsApp is not on your laptop or something like that. So you can just drop your number with me directly. My name is Yobusa. Just search it in the chat section and send it to me directly in case you don't want to give out your number. So just send it to me directly and someone will add you. I can take the number and add it to the group chat later on. So if that's fine by you. So you can just do that within the next 1 minute. Okay. So okay, just let me take this. Okay, let me just take this number. Give me a minute. Okay. Okay, so I've gotten a number, Mr. Shina and Miss Precious. I've gotten the numbers. So Professor Shina, I've gotten a number. So someone will add you to the group chat if you're not already in the group chat. And thank you very much for being a part of this meeting today. Thank you so much. So I hope you all have a great evening ahead. And I think we'll be here again on Friday. I'll be taking the session again on Friday. So thank you so much. Have a lovely evening. Thank you.